All right, everybody, welcome to Math with Grace. Today we're going to be working through Pre-Calculus, Unit 10, Section 2. Section 2 begins on page 23 and it's titled Slopes and Curves. And it says here the slope of a line can be found in several ways. However, the definition of the slope of the line, and they use the letter M to represent slope, okay? M is equal to the change in y over the change in x, okay? Demonstrated here. Then it goes into a pretty complicated formula to find the slope of a line. But the slope of a line can be found fairly easily. So let's turn the page and take a look at these. So when we turn to page 24, we see that they have the definition of the slope of a function being the formula of the limit of the difference quotient as h approaches 0, right? And this will be great for functions as we move forward, but for slopes of lines, we don't need to go this far, because if you remember, when we have the slope formula, y equals mx plus b, m is the slope, x is just an x, and then the b is where it crosses the y-axis, okay? So if we just have our function, so it would be f of x equals mx plus b, then we can easily find our slope. So looking at these examples, f of x equals 5x plus 6. 5 is my slope. And going through the formula, they come to that same conclusion. Now, we'll have plenty of opportunity to practice this formula moving forward. So don't be like, oh, well, I'm going to practice. No, we'll have plenty of opportunity to practice moving forward. Let's not make work harder than it needs to be, okay? And so when we're talking about a line, and remember, a line is a variable to the exponent of 1 and a constant. Sometimes it's just the variable, sometimes it's just the constant. But if it has a variable with the exponent of 1, it is a line. And lines can be set up in this way, and the slope can be found very easily. So this next example, find the slope of the function f of x equals 7 minus 2/3 x by the definition of limit. Now, negative 2x over 3 is the same as negative 2/3 x, okay? 2/3 then being the slope. 2/3 being the slope, which is what the conclusion they come to as well, right? So this formula is great. We're going to use it. Let's not make it harder than it needs to be, though, okay? Final example here. F of x equals 3x plus 4. Again, the slope is just 3. Okay? So, for this first part, super easy. We'll do a couple of these together, and then we will go on to the next part where we actually get into using this formula for something a little bit more complex, okay? So find the slope of the function f of x equals 2x plus 3 by the definition of limits, but the slope is 2, right? Because it's here, y equals mx plus b. So the coefficient of the linear term is what it's called because it's a line, but the variable to the one exponent, the coefficient of that is our slope. So for number 2, fx equals 3 minus 2x, the slope is equal to a negative 2. All right, down here at number 8, find the slope of the function f of x is equal to negative 7x plus 4 over 2. If you have to think about this one as if I broke it into 2 fractions instead of 1, right? I don't care that reduces, it's not what they're asking, but our slope is right here. Our slope is equal to negative 7 over 2. Right? And the same goes for number 9, right? F of x is equal to negative 8x plus 5 over 7. Again, we would just break that into 2 pieces, right? So our slope is equal to negative 8 over 7. So on and so forth, all right? Let's not make it harder than it needs to be for this section. I mean, let's not make it harder than it needs to be ever. But for this section, in particular, using this formula is a bit too much when we already know this formula for the slope, or for the equation of a line, right? The slope formula is what it's called. Okay, finish the rest of these on your own and then meet me back here for the next part. All right, so here on page 26, we start the next section of this, the next part of this section, slope of a curve. And it states here that the slope of a curve is defined as the slope of the line tangent to the curve at a given point. So they've got it represented here, right? Here is our curve, and here is our tangent line. But it could be at any given point along this curve, right? The slope of the curve is variable then. If our tangent line can move, obviously its slantiness isn't going to be the same everywhere. The slope is not necessarily the same from point to point. As x increases, in this particular case, point P moves up the curve and the slope of the tangent line increases. So here's where we use the difference quotient and limits to figure it out, okay? And so they're just continuing to talk about how the points move, right? It says to justify the definition of a slope, we find 2 points on the curve and draw a scant line through the 2 points. Now, if we move Q closer and closer to P, it's the same as our H approaching 0, right? But remember, the statement H approaches 0 does not mean that H ever reaches 0. The statement means that H gets infinitely close to 0, thus retaining both points. So Q is going to get infinitely closer to P, but never actually reach P, okay? That's how we figure this out. So on to the next page here. It says in figure 4, the secant line through points P and Q is this difference quotient, right? As H approaches 0. That's how they have it set up. Okay, so using the difference quotient, which we already have some experience with, let's take a look at these examples. So let's find the slope. F of x equals x squared at the point x equals 3. So we need to save this part for later, okay? And we're just going to deal with this x squared for now. So remember the difference quotient, right? So we have x squared, so we have the quantity x plus h squared, because we're putting this into our variable, minus f of x, which is going to be minus x squared. We're going to square double square this, so we get x squared plus 2hx plus h squared minus x squared. So my x squareds are going to cancel, right? And I'm left with 2hx plus h squared over h. But then I can reduce, since they all have at least one h, right? I can reduce like this. You can see how the book has already gone right to the answer, but I'm going to show you how they got there. So we're left with 2x plus h, right? Then we put in our limit just like before. And so if h is approaching 0, then I have 2x plus 0. So my slope is 2x, okay? Now my slope is 2x, but what they want to know is what is the slope at x equals 3. And now here is where we bring down that x equals 3 and we stick it in right here, and we find that the slope is 6. At that particular point, the slope of this curve is 6. All right? All right. Continuing, finding the slope of a complex curve, we have this example. Find the slope of f of x equals x to the third plus 3. Right? Well, we're still using the difference quotient, right? So x plus h is going to go in here. So we have x plus h, the quantity cubed, plus 3, minus f of x, which is x to the third plus 3. Okay, now, if you don't know how to expand a cubed thing, I will set that up for you right now. So if we think of this in generic terms, right, we have a plus b cubed. Okay, that's what we're dealing with here, right here, right? A plus b cubed. In this case, a is equal to x and b is equal to h. Okay, to multiply that out, and just have like a formula to represent it, right? It's set up like this. A to the third plus 3a squared b plus 3ab squared plus b to the third. That is the general representation of this. And then you would just put in your x or your h. Now, the reason I show it to you like this is because sometimes our x isn't just an x, right? Sometimes our, actually this is an x. No, that's right, x cubed. Okay, x. Because sometimes our x is a 2x, or it's a, 1/2 or whatever. Sometimes there's coefficients, and when there's coefficients, then you can stick that in there too and then do the multiplying, and it would look like this. I mean, that's what they have here in essence, right? Except they put the x's and the h's in where they belong. So when you're done, you just resubstitute in your a's and b's, or you follow this formula and say, okay, for the first term, I have a to the third, so it's x to the third. My second term is 3 times x squared h, 3 times x h squared, and then h to the third. But if, for some reason, you have an a and a b here, right, that have coefficients, then this, setting it up this way, in my opinion, using this formula, makes it kind of easy. I think it's not really a formula. They call it a model or whatever, right? It's just that this is equal to this, okay? That being said, I just wanted to tell you that in case there's a problem going forward that is a little bit more complicated with a coefficient or whatnot. This is the model that you would follow, okay? Now, if there by chance was a negative in between here, it's not going to work or be a problem or an issue, I guess, with our difference quotient, because it's always positive here. But if there were a negative, then this sign here would be the one sign that's different, this negative sign. All right, anyway, moving forward. Okay, so that is what they have right here, is the expansion of this. Then they have their plus 3, and then they've distributed their negative throughout. So negative x to the third minus 3. So my minus 3 and my plus 3 cancel. My negative x to the third and my positive x to the third cancel, and it's left me with this bit here. And I can cancel out an h from each of these, and this now becomes a square, right? Which is what they have here. And then because I'm approaching 0 with h, I'm going to put a 0 in for my h's, and all that's left then is this 3x squared, okay? So that is the slope, right? But they've asked, they haven't asked for a point. So the slope at any given point is going to be 3x squared. And then once you're given that point, you can find out what the true slope is for that particular point, right? All right, let's turn the page. Here on page 28, we have a couple more examples we're going to work through. Find the slope of f of x equals the square root of x. Now, we're still using the difference quotient, so we have f of x plus h. We're going to substitute that into our radical, so we have the square root of x plus h minus the square root of x, all over h. Now, when we're talking about functions that involve radicals, we want to rationalize the numerator by multiplying it by the conjugate. Remember, the conjugate is exactly the same terms, but the opposite sign. So it's going to be the square root of x plus h plus the square root of x. And we do that over itself because then you're technically multiplying by 1 and you're not changing the formula at all. But when we do that, right, this becomes a sum and difference binomial, right? If we put parentheses around it, it's a sum and difference binomial. So we square the first term, and when we square a radical, right, we lose the radical sign and it's just the what's underneath. And then we square the last term, and so it's just going to be an x with a negative in between. So now we have x plus h minus x all over h times all our radical bits, okay? Our x's are going to cancel because x minus x is 0, so we're just left with the h, but then our h's cancel here, and so we have 1 over the square root of x plus h plus the square root of x. Now, as our limit approaches 0, we replace this h with a 0. So we end up with the 1 over the square root of x plus the square root of x, which is 2 times the square root of x. So 1 over 2 times the square root of x is our slope. Of course, the slope is undefined at x equals 0. And this is the slope for any given point on this curve. Okay? One more example here. We have find the slope of x squared plus 3x minus 2. Again, we have our difference quotient. So we have f of x plus h is the first part, and the first part goes all the way to here, right? So we have x plus h squared, and then we have 3 times x plus h, and then minus 2, and then minus f of x, so minus the quantity x squared plus 3x minus 2. Remember, the minus applies to the whole thing. We have to do it piece by piece. All right? So expanding this perfect square binomial, we have, or this binomial squared, is x squared plus 2xh, right? We square double square, plus xh squared. Then we distribute the 3. So we have 3x plus 3h minus 2 minus x squared minus 3x plus 2. Okay? So my plus 2 minus 2 cancel. My minus x squared, my plus x squared cancel. And my negative 3x plus 3x cancels. And I'm left with 2xh plus h squared plus 3h. My h's, since they each have 1, I can cancel. Okay? And I'm left with 2x plus h plus 3. As h approaches 0, so I put a 0 in here. And this should be m equals 2x plus 0 plus 3. So my slope is 2x plus 3. Okay? At any given point along this curve, my slope is 2x plus 3. All right. So, difference quotient at work. We have some experience with this, so it shouldn't be something new, right? We're just using it in a slightly different manner. So find the slope of the curve. F of x equals x squared plus 2. This is a curve because our x is to a squared, right? It's not just to a single exponent. So we're going to use our difference quotient, which is the limit, or the slope equals the limit, as h approaches 0 of f of x plus h minus f of x all over h. Okay, so right there, so we can use it for each formula. So I have f of x plus h. So x plus h, the quantity squared plus 2, that's this first part, minus the quantity x squared plus 2, all over h. Okay, we'll worry about this part. I'm not going to rewrite that every single time. We have to square this binomial. So we square double square. We square the first term, so x squared. We multiply them together, which is x times h, and then double it. So 2xh, and I know it should be written hx, but since h is going to be canceled, I'm just leaving it to the end, right? And then we square the last term, which is the h squared. Plus 2, we have to distribute this now, so negative x squared minus 2 all over h. So negative x squared, minus 2 plus 2, I was going to say it was somewhere. I'm left with 2xh plus h squared over h. Since they all have an h, I'm going to cancel 1 from each. And so this is equal to 2x plus h. H is going to be equal to 0, since that's what our limit is approaching. So my answer is just the 2x. So letter C. Let's do the other one on this page here, and then we'll take a look over there. It says the slope of the curve, f of x equals x squared plus 2 at 3, x equals 3. So now we have the slope, right? The slope is equal to 2x. So at 3, the slope is equal to, this looks very familiar, the slope is equal to 6, letter C. Okay, let's take a look over here at problem number 22. for problem number 22, it says find the slope of the curve f of x equals x squared minus 8. All right, or sorry, minus 8x. So this one's slightly different, right? So if we have f of x plus h, then we have x plus h, the quantity squared, minus 8 times x plus h, that's the first part, minus f of x, which is x squared plus 8, or sorry, minus 8. All over h, okay? Now, we have a lot of expanding to do. We've got to distribute here, and we have to expand this. So, square, double square. X squared plus 2xh plus h squared minus 8x minus 8h minus x minus x squared plus 8. Okay, so plus 8. Oh, I don't have a minus 8 this time because my minus 8 is tangled up in a, and this is supposed to be 8x. That's my problem. Plus 8x. Okay. Make sure you're copying things over correctly, right? Now I have positive 8x and a negative 8x. Gone. I have a negative x squared and a positive x squared. Gone. I'm going to rewrite this one because it's gotten a little sloppy, right? So I have 2xh plus h squared minus 8h all over h. Okay. Canceling out my single h from everything leaves me with 2x plus h minus 8. Okay. My h, remember, is approaching 0. It's the limit as h approaches 0. So this becomes a 0. So I have my slope is equal to 2x minus 8, right? Which is letter B. So what then it says for the next problem, find the slope of the curve 2x minus 8x, or x squared minus 8x at x equals 0. Now, we already have the slope figured out, so the slope is equal to 2 times 0 minus 8, or the slope is equal to a negative 8 at that particular point, which is letter C. Okay, so difference quotient. Careful when you're putting stuff in that you write it in correctly, right? But go ahead and finish the rest of these on your own, and then meet me here for the next part. All right, the next part of this section begins on page 30, and it's titled Angle Between Curves. It says the formula for the angle of intersection of two lines is this formula, okay? Where we have the tangent of theta equal to slope 2 minus slope 1 over 1 plus slope 2 times slope 1, okay? So, taking a look at this example, it says find the angle of intersection of the line f of x equals x plus 2 and the parabola g of x equals x squared. Okay, here's my line, and here is my parabola, right? They want the angle of intersection. Well, it intersects at 2 times, right? Technically here and here. And so it's 2 different angles that we will be figuring out. I assume it is this angle and this angle, since we probably stay above the line. But let's take a look. This example takes up this whole page. So let's take a look at this bit by bit, try to keep it all on screen here. Okay. It says first we have to solve the system y equals x squared, or sorry, x plus 2 and y equals x squared using substitution. Since y equals both of those things, they can set them equal to each other. So x squared equals x plus 2. They moved everything over to the left side of the equal sign and then factored. So they got 2 answers, right? X is equal to 2 and x is equal to negative 1. So positive 2, negative 1. Now, they don't spend their time figuring out the y variables, just the x. So we don't have exact points, but we know where the x value is because it's when x equals this, when x equals that, right? So that's what they had to solve for. Then it says find the slope of each curve. Now the line, the slope is just 1, right? We know that from right here. So let's not go too crazy, right? And this is m sub 1 is equal to 1. And then they need to find the slope of the curve, which is g of x equals x squared. So using the difference quotient, we have square double square, right? X squared plus 2hx plus x, or h squared minus x squared. So our x squareds are canceled. We cancel an h, right? And so we're left with 2x plus h. It's as we're approaching 0, so this h becomes a 0. So the slope sub 2 is equal to 2x. All right. Then it says for the first point where x equals 2, we find the slope of the curve. So we found that m sub 1 equals 1, right? Then we find the next point, or sorry, we use the other slope formula to find where it crosses 2. And so m sub 2 is equal to 4, right? Because this has an x in it, so it's got to be 4. So now we have our m's. M sub 1 is equal to 1, and m sub 2 is equal to 4 at the point x equals 2. Now they can plug them into this formula. So I have 4 minus 1 over 1 plus 4 times 1, right? So 4 minus 1 is 3, 4 times 1 is 4, plus 1 is 5. The tangent of 3/5, they're going to solve for actual theta, right, by doing the opposite or inverse tangent on the calculator. I guess I can show you real quick how to plug that into your calculator. So remember, usually it's just right underneath the actual tangent button. So you would hit shift tangent, and then I would do 3 divided by 5, close your parentheses. I don't even know if you can see that, equals, okay? And it comes up to 30.9 or 31 degrees, okay? So that angle is 31 degrees. But remember, we had 2 points, right? It crossed at 2 and -1. Well, the slope m sub 1 is not going to change because it is a constant. It's always going to be that. But m sub 2 does change because now the slope at m sub 2 is a -2, okay? So we're going to end up with -2 minus 1 over 1 plus -2 times 1, or -3 over -1. My negatives cancel. The tangent of theta equals 3, so theta is equal to 72 degrees. All right? And so those are the 2 angles. Again, I don't know if they mean these 2 or if it's this one and this one. You know, I'm not 100% sure. But those are the 2 angles of intersection between this line and this curve. All right. Again, this is really nothing new. It's just using it in a different way. Okay. So let's turn the page and take a look at some of these. So for problem number 27 on page 32, it says, find the obtuse angle of intersection between the curve f of x equals 2x plus 3 and g of x equals -3x plus 1. Both of these are lines, okay? So because I don't have an exponent greater than 1, right? So they're both lines. So m sub 1 is equal to 2, and m sub 2 is equal to -3. All right, first part complete. Now we need to see, where do they intersect, right? That's what we have to figure out. So because these can both be written as y equals 2x plus 3 and y equals -3x plus 1, we can set them equal to each other. So substitution tells us that 2x plus 3 is equal to -3x plus 1. I'm going to add 3x to both sides, and I'm going to subtract a 3 from both sides. Okay, so those 2 things cancel out. I have 5x is equal to -2. So x, where they cross, is equal to -2/5. All right, so now we just use our formula for the angle of the curve, which is the tangent of theta is equal to m sub 2 minus m sub 1 over 1 plus m sub 2 times m sub 1, okay? So m sub 2 is a negative 3 minus m sub 1, so minus 2 over 1 plus negative 3 times 2, okay? So negative 3 minus 2 is a negative 5. Negative 3 times 2 is a negative 6, plus 1 is a negative 5. So my slope here is 1. So the tangent of theta equals 1. And if you remember back when we were dealing with this a lot, that is going to be 45 degrees. But let's check it on our calculator, okay? So we have the inverse tangent of 1 is equal to 45 degrees, okay? So the answer is letter A, which fits in right there, all right? Find the slope of the curve f of x equals 2x squared. Okay, see how we have a number here now. It makes a difference, right, as we're using our difference quotient. So we have f of, it's right over here in case you forget what it is, f of x plus h. So I have 2 times x plus h, the quantity squared, minus f of x, so minus 2x squared, okay? All over, h. All right, so let's expand all of this. I have 2 times square double square, so x squared plus 2xh plus h squared minus 2x squared all over h, right? I need to expand this now. 2x squared plus 4xh plus 2h squared minus 2x squared all over h. So I have plus 2x squared minus 2x squared, okay? Then I have 4xh plus 2h squared over h. I'm going to cancel the h's where I can. So I'm left with, I'll just write it in between. They don't give you a lot of room. 4x plus 2h over, oh, nothing. Our h is canceled. So 4x plus 2h is where we're at. H is approaching 0, so this technically is gone. So the slope is 4x, which is letter C. Let's see if we can find one here for the angle of intersection. Oh, you know what I messed up on this one? It says find the obtuse angle of intersection. So while this angle of intersection is 45 degrees, remember there's going to be 2 angles at least on where these cross. So we would take 180 minus 45, because when 2 lines cross, right, this is, say this one's 45, we're trying to figure out this one. 180 minus 45 would actually be 135. Ah, see, they almost got us. They almost got us. I just noticed that on our way. Okay, letter C for 27. All right, angle of intersection, because the curve ones we've done already, but let's find our angle of intersection here. Let's practice another one of those. Find the angles of intersection between the curve f of x equals 2x squared and g of x equals negative 7x minus, or 7x minus 5, not single. So the m sub 2 is equal to 7. That's a line. That one's done. The slope of 2x squared, we just found that out up here, right, as being 4x. So m sub 1 is equal to 4x. Okay, now we need to figure out where these 2 things cross each other. So we're going to set them equal to each other. I'm going to do it on this side over here. 2x squared is equal to 7x minus 5. Moving everything over to the left side, I get 2x squared minus 7x plus 5 equals 0. Now there's several different ways that you could factor this, or that you could, you know, get it to be factored, but we're just going to take a look real quick at the numbers here, because here we're given a prime number. It is a positive 5, but here we have a negative 7. So that tells me to get a positive 5 that I took negative 5 times a negative 1. It's the only way to get 5. 5 times 1 in some form. To get this to be a negative, I need these both to be negative. Okay? Now, obviously, 5 plus 1 is not 7. So somewhere this 1 needs to become a 2. And that's going to happen right here if I put this 2x here. If I put the 2x here, I would never be multiplying those two things. So, x minus 1 times 2x minus 5. Let's check it, though. X times 2x is 2x squared. X times negative 5 is negative 5x. Negative 1 times 2x is a negative 2x. Adding negative 5 and negative 2x gives me negative 7x. Negative 1 times negative 5 is 5. So we have factored correctly. We set each one of these equal to 0 now. So x equals 1. That's one place that they cross. And x equals 5 halves is the other place that they cross. All right? So the angles of intersection between, we have to use both. So for x equals 1, we'll do that first. I have, remember we're using, oh, it's off the screen. We're using this formula here, okay? So for x equals 1, my m sub 2 is not changing. So I still have 7 minus, my m sub 1 is going to be 4 times 1, which is 4. Okay, so m sub 2, or sorry, sub 1 is 4 for this particular point. So I have 7 minus 4 over 1 plus 7 times 4, which is going to be 3 over, this is 28, 29, right? 3 over 29. So remember, the tangent of theta is equal to 3 over 29. So theta is going to be what? Let's grab our calculator. We have the inverse tangent of 3 divided by 29, close your parentheses, and we get 5 point, I don't know how to do it so I don't get the ring on there too, 5.906. So 5.9 degrees, okay, for the first one. Then for where x is equal to 5 over 2, okay, we have m sub 2, which is 7, minus 5 over 2 times 4. So let's go like this, 5 over 2 times 4. We've totally encroached on this one. Sorry, problem 31. Is going to be 10, right? So 7 minus 10 over 1 plus 7 times 10. Or 3 over 71. Again, the tangent of theta is equal to 3 over 71. So theta is equal to, we're going to do the reverse tangent of 3 divided by 71, close my parentheses, equals, and it's 2.419, so 2.4, we'll call it, degrees, okay? All right, so I see my mistake. This was negative 3, right? Which means this is a negative 2.4. And if we remember our, right, all students take calculus, our tangent is negative here, okay? Well, here technically as well. So negative 2.4 degrees, we would actually take 180 and subtract that. And so it would be this. So A and C are the two answers for this particular problem. The reason I know that it's not in this quadrant is because the numbers aren't big enough, right? They don't give me that much. So they must be aiming for quadrant 2, which tells me it's this here, because that's where my tangent is negative. All right, so they're throwing in a little bit of, you know, like book, I don't even know, 5 or 6 stuff here. Right? Okay. That is the example of how we do these. Go ahead and finish the rest on your own, and then meet me back here for this last part. The last part of section 2 is called derivatives. Okay? And it says a derivative is a function that defines the slope of a tangent line to a curve. We've actually been, it says up to this point, you've been calculating slopes of curves and limits using this formula. And there are some rules we can use to make the process faster. It says we want to find the derivative, we want to find the derivatives of a function. We write d over d of x in front of the function such that d over d of x of f of x equals 2x. Once the derivative is found, we write it as f prime of x equals 2. Okay, and that's the little check mark here is called the prime. And so here are a couple of the rules we're going to look at. First rule of finding derivatives is the constant rule. So if we are finding the derivative of a constant, it's going to be equal to 0. It says a constant function is always going to be graphed as a horizontal line. A horizontal line always has a slope of 0. So it makes sense that the derivative on a horizontal line will always be 0 because the slope is always 0. Right? Let's turn the page. Now, if you're like me, you probably found this very annoying. At first I tried to erase it because I thought maybe someone wrote in my book, but let's try to overlook this scribbles here and keep looking at our examples here on page 34. Find the derivative of f of x equals 2. Well, this is a constant, so the derivative f prime of x is 0. Same for this. Find the derivative of 7.34. Well, the derivative of 7.34 is 0 because it's a constant. Okay? Now, the other rule that we're going to look at is the power rule. Now, we've been working all this time using our quotient, right, to solve, but apparently there is a quicker, faster way. And so if n is a positive integer, then the derivative of x to the nth power is equal to n times x to the n minus 1 power. And so before you look at that and you're like, that makes no sense, let's take a look at it. The derivative of f of x equals x to the 4th. We're going to take that 4 and we're going to stick it out front of the x, and then we're going to make the 4 that was there a 3. We're going to subtract 1 from it. So the f prime of x is 4x to the 3rd. Or basically, this is the slope of that line, or this curve. The slope of the curve is 4x to the 3rd. Find the derivative of x to the 11th. Well, it's going to be 11x to the 10th. This is the slope of this curve. All right, so it's kind of like a cheater way of finding the slope. So, looking at the problems on page 35, we have problem number 34. Find the derivative of f of x equals 9. So f prime of x is equal to 0 because this is a constant. Same for 35. The derivative of f of x equals a negative 15 is that f prime of x is equal to 0. Okay? Looking at number 38, find the derivative of f of x equals x to the 21st. Well, f prime of x is going to be 21x to the 20th. All right, we move this up front and we take 1 away from it, and that's what we end up with. The derivative of f of x equals 0 for number 39. 0 is a constant, so f prime of x is equal to 0. And last but not least, I'll leave you a couple to do on your own. These are pretty basic. F of x equals x to the negative 4th. So f prime of x is going to equal negative 3x to the negative 3rd. Actually, we're subtracting 1, so it's probably to the negative 5th. And not probably, that's what it is, because remember, we're subtracting 1. So it's negative 3x to the negative 5th. Or not negative 3, it's not even negative 3, geez. It's negative 4, because the negative 4 comes out front. X to the negative 5th. Yikes. Okay. Don't know where my head was at on that, sorry. So f of x equals x to the negative 4th. F prime of x is equal to negative 4, x to the negative 5th. All right. There's a couple left here to finish on your own. That is it for the book. And not only is it for this book, but it is it for this curriculum. Great job. You've made it all the way through to the end. You've done fantastic. You should be proud of yourself. If you have any questions, don't hesitate to contact me. Otherwise, have a great day, and until next time.